Hi everyone. So today we will see about the so SF6 circuit breaker. Okay. So circuit breaker, as we know, it is used to isolate the faulty part in the power system. Okay. So the medium, the here there is the circuit breaker classification. Mainly, it is based on the arc extinguishing method. So the medium in which the arc extinguishing of the circuit breaker, which influences its characteristics also, okay, characteristics and also the lifetime of the circuit breaker. Okay, so mainly if you are going for vacuum circuit breaker. Okay, so this vacuum circuit breaker, if you are using, it is restricted to a system voltage below 38 kV. Okay, so these characteristics of the vacuum will be as it is used for the medium, and also the cost for that vacuum circuit breaker, it doesn't make suitable for the voltage ranges exceeding 38 kV. Okay, so if you are going for higher transmission, we have the oil circuit breaker. Similarly, the air blast circuit breakers are used. Okay, so nowadays, these days, the transmission voltage levels of the transmission voltage levels for transmission voltage levels above these ranges, mostly these SF6 circuit breakers are used. It is used for the lower voltages. Okay, if it is 11 kV, 6 kV, all those things we are going for this SF6 circuit breakers. Okay, and here the arc quenching medium is SF6, or it is sulfur hexafluoride. Okay, the sulfur hexafluoride, it is a gas. Okay, so it satisfies the requirements of an ideal arc quenching medium. Okay, also this is extensively used in the circuit breakers from 3 kV and also up to 7 kV. Okay, 3 kV to 765 kV, it is being used. Lower voltage levels like 3 kV, and also it can be used for higher voltage levels up to 765 kV. Okay, 765 kV. Okay, so here the main properties is that why we are going for SF6 circuit breaker. So here, okay. So why we are choosing the SF6 sulfur hexafluoride? Okay, why we are being using the sulfur hexafluoride, because it is having a high dielectric strength. Okay, and also the arc quenching capability of sulfur hexafluoride is also very high. There is high cooling effect. Okay, and also when we are going for the other types of circuit breakers, air circuit breaker and all, this SF6 circuit breakers is having higher effective, that is, it is having more than 100 times more than effective arc quenching medium than your air. Okay, and also we can use, the main application is that we can use for medium level and also up to very high level, medium level to high level applications, the circuit breakers we can use. Okay, so now we will see about the construction of your SF6 circuit breaker. So here you can see the diagram of your SF6 circuit breakers. Okay, so this is actually very effective for high power and also for high voltage service. Okay, so when we are coming for the construction of the SF6 circuit breaker, in the diagram, you can see it is having mainly, it is having, so here you can this one you can see the main parts of the circuit breaker. So here we are having mainly the interruption unit and also the gas system. The gas has to be uh, the gas has to enter into the circuit breaker. Okay, so mainly it is having mainly two parts. One is the interrupter unit, and also the second one is the gas system. Okay, so what about the interrupter unit? The interrupter unit of this system only is having this fixed and the moving contacts. Okay, so with the help of this fixed and the moving contact only, the arc quenching is going to happen, which is enclosed in a chamber. Okay, so it will be enclosed in a chamber. This chamber, it is normally this chamber is termed to be the arc quenching chamber, or it is arc interruption chamber. Okay, so this arc interruption chamber only, there only we are having this gas also, SF6 gas also. Okay, so this chamber will be filled with the SF6. Okay, so we will be having an SF6 reservoir, gas reservoir will be there. So the gas reservoir will be connected to this arc interruption chamber. Okay, and also we'll be having a valve mechanism. Valve mechanism will be there to permit the gas to enter the arc interruption chamber. Okay, so when the contacts of the circuit breaker are open, the valve mechanism it will permit the high pressure SF6 gas from the reservoir towards the arc interruption chamber. Okay, so here you can see here you are having that SF6 gas inlet is there. So here you are having the moving rods. Moving rods are operating members. Here you are having a moving member. So this is about your gas outlet mechanism. So here you are having. So here you are having a fixed member. This one the contacts. This one is the arc chamber. So from here only that from the reservoir the gas is being allowed to enter into the chamber with the help of the valve. Okay, the fixed contacts will be a hollow cylindrical current carrying contact which is fixed with an arcing hump. Okay, so the moving contact is also here we are having two chambers. One is fixed contact and one is moving contact. So this fixed contact will be a hollow cylindrical current carrying contact which is fixed with the arcing iron. Okay, and also the moving contact, it is also a hollow cylinder with a rectangular holes on the sides. Okay, so the purpose of this holes that is that it permits the SF6 gas outlet gas outlets to flow after flowing, and also it will help to extinguish the arc. Okay, the tip of the fixed contact where you can see in that yellow. Okay, so there the fixed contact, moving contact, arcing con, all these are being coated with the copper tungsten arc resistant material. Okay, so mainly this SF6 is costly. Okay, so hence we are reconditioning this and reconditioning the gas after each operation of the breaker. Okay, so how the gas system, no, this since the gas pressure is very high, a lot of care has to be taken that the gas should not there should not be any leakage in the gas. Okay, so normally this circuit breaker this one, this SF6 circuit breaker, mainly we are having this following types also. Okay, so we are having a non-puffer type, then we are having a puffer type. Okay, so single puffer type, and also we are having a double puffer type. Okay, so this now we will switch on the so here you can see the diagrammatic representation. This is the pictorial of here. You can see this one is here. The first one which you are seeing is the SF6 circuit breaker. So here you are having this one is the oil circuit breaker. Again, this is the SF6 circuit breaker which is used in the substations. Okay, and coming to the types of the SF6, we are having non-puffer type, then single puffer type, and also we are having the double puffer type. Okay, so here which we have seen the diagram, diagrammatic representation is of non-puffer type. Okay, so this is what we have seen, the non-puffer type. Okay, so this SF6 gas, the gas is also it won't have be any color, it won't have any order. So it will not be having any order or something. Okay, so how we'll be making no this SF6, we will be that sulfur hexafluoride, that gas will be there. So we have to the working of the some SF6 circuit breaker is similar to the working of the normal circuit breakers only. Okay, so in the closed position of the closed position of the breaker, the contacts will be remain surrounded by the SF6 gas. Okay, and it will be having a pressure. Okay, so when the breaker is opening, when there is the movement in the breaker, so the moving contact it will be pulled apart, and once the moving contact is pulled apart from the fixed contact, the arc will be struck between the contacts. Okay, so when the arc is struck between the contacts, the moving, that is the movement of this moving contact is synchronized by the opening of the valve. Okay, at that time the valve permits the gas sulfur hexafluoride at a high pressure of almost 14 kilogram per centimeter square from its reservoir to the arc interruption chamber. Okay, so in the normal working normal condition, that is in the closed position of the chamber, these contacts will be surrounded by the SF6 gas, and at that time the pressure will be only around of 2.8 kilogram per centimeter square. So when the breaker, when the signal has been given from the relay, the breaker will be opening. So when the breaker is opening, the moving contact will be pulled apart from the fixed contact. Once the moving contact is pulled apart from the fixed contact, the arc will be stuck between the contacts. Okay, so this movement of this moving contact, it will be synchronized with the opening of the valve. Okay, so the valve only we are having that in that gas reservoir only we are having the SF6 gas. Once it is moving, the valve will permit the SF6 gas at the inlet of this gas at a very at a high pressure of around 14 kilogram per centimeter square from the gas reservoir to the arc induction chamber. Okay, so this high pressure flow of gas, it will rapidly absorb the free electrons in the arc path. Already the arc is existing between the contacts. Okay, so when this gas, when this inlet of the gas will be from the high pressure SF6 gas, it absorbs the free electrons from the arc parts. Okay, so it also forms the immobile negative ions, which which will be ineffective as a charge carriers. Okay, once we are having the immobile negative ions are there, there will be no effect of the charge carriers. Okay, so this will result in a medium between the contact that will quickly build up a dielectric strength, and this will causes the extinguishing. This will cause this is how the arc extinguishing is happening. Okay, and we'll come with the types of your circuit breaker. Okay, so here we have the two types, the non-buffer type only we have seen. Okay, so next we are having the double buffer type and the single buffer type as a circuit breakers. Okay, so in the single pressure buffer type, there we will be having two chambers will be there. Okay, so one will be one that is which we have seen single pressure type. The gas will be compressed by the moving cylindrical system, and it will be released through a nozzle while extinguishing the arc itself. Okay, so this design of the SF6 circuit breaker, it is used for voltage ranges from 13.6 kV to 760 kV. Okay, so in the case of double buffer type, so we are having one more type, that is the double buffer type. Okay, so here the gas will be released from the high pressure system to the low pressure system through a nozzle. Okay, during your extinguishing process itself, we will be having a high pressure system. The gas will be released from the high pressure system towards the low pressure system. Okay, so so what we have, double pressure system is worked. It is mainly based on that air blast circuit breaker. Okay, so it is mainly based on the air blast circuit breaker. Okay, and and these designs in the era of 1970s itself, the circuit breakers came into existence. It is suitable for both indoor and outdoor installations. Okay, it is mainly used with its that reservoirs with this indoor and outdoor units. Okay, and also we are having rather than it is require only a very short arcing time. Okay, also the dielectric strength is also very high, 2 to 3 times of air, and the arc quenching capacities we have seen, it is around 100 times more than that of the air. Okay, and also we will have a noiseless operation also, and also it will closed gas enclosure will be keep us dry. Okay, so there will not be any moisture problem since everything is happening in a closed enclosure. Okay, and also there is no risk of fire as our this one SF6 is of a non-inflammable. Okay, after the quenching also we don't have any carbon deposits. Okay, maintenance is also very low. We can reuse we can go for reusing this SF6 gas. Okay, and also it require only minimum auxiliary equipments. Okay, and since it is inflammable, it can be suitable for explosions. It can be suitable for explosion hazards. Okay, so only the disadvantage here is this one is very high cost. Okay, cost wise it is very high. Okay, so we have to be after every operation of the breaker, this gas has to be reconditioned. Okay, so for reconditioning the gas, obviously we require the additional equipment. Okay, so that here you can see the single puffer type. Okay, so the single puffer type, and here this one is of a double puffer type. Okay, here we can see the double puffer type. Okay, so mainly low voltage to high power generators in for high generator protection also we can go for this SF6 up to 30 MVA to 1800 MVA. Okay, as 11 kV to for transmissions, for 11 kV to 765 kV. Similarly for generator protection also we can use this SF6 circuit breaker. So 30 MVA to 1800 MVA. So it is a reliable, fast and economic breaker, and also it is having the high current capacity from 4 kilo ampere to 40 kilo ampere, and also having a high breaking capacity from 50 kilo ampere to 275 kilo ampere. Okay, so that's all about our SF6 circuit breaker. Let us stop here. Thank you all.